Hi guys, this is Mohit from Indian iOS Guru and I'm back after a long time with a video. I'm taking a slight shift from my Basics with Swift series, and this video is going to talk about some advanced concepts like machine learning in Swift. I have been trying my hand at machine learning for quite some time now, and if you're anything like me, you should be super excited to know that Apple has launched CoreML at WWDC 2017. The website for CoreML is up at developer.apple.com/machine-learning. Now, the machine learning stack that Apple provides us with is, as you can see on this diagram, you have your applications sitting on top, and right below that, you have vision and natural language processing sitting at the same layer side by side, and you have Core ML right underneath these layers. So this core ML layer is where we're going to be focusing this video on today. Now, the way core ML works is that you use any of these open source tools to train your model. Then you pass the output of these tools to the core ML Python library, which generates a .ml model file which you drag and drop into your Xcode project, which will then generate a Swift class for you. So going back to Apple's website, scrolling to the bottom, you can see that Apple gives us 4 models to start with and has committed in their WWDC videos to provide us with more. So that's awesome. All right, let's get started with code now. What I'm going to be doing in this session is I'm going to build a simple application that gets a random image from the internet, and I'm going to use this Google Net model to detect the scene in the images. So let's get started. I'm going to fire up my Xcode beta. Get started with a new Xcode project. Let's create a single view app. I am going to call this my intro core ML. Hit next, create, and there you go. We have a project ready. So the version of Xcode that I'm using for this video is the first 9.0 beta, which is build 9M136H. Let's go over to the storyboard. Let's take an image view. I'm going to make this image view a nice square. So I'm going to pin this to top, left, right. And I'm going to set the aspect ratio 1:1. I'm going to have a button. Refresh. Center and align this button. And let's have a label. Okay, let's make some outlets. Call this image view. Create an action for this button. And let's call this the output label. So it's a simple view controller. I have the output label, I have the image view, I have an action for this refresh image. Um, don't quite need the view did load. Let's just get rid of it. Don't need the did receive memory warning. All right. So it's a simple class, just 3 lines, 4 lines of code at this point. And now what I'm going to do is I have already written out some code, which is my extensions.swift and image downloader.swift. So these two files are basically helping me get the image from the internet. And to get an image from the internet, all I have to do is use my image downloader class. So you can see this class is designed to be a singleton. It has one function, which is download, and you pass it your URL as a string, and you use the completion handler. And in this completion handler, you'll get the image back, and you can see that this function is completely thread safe. It dispatches asynchronously, gets the image, and then it dispatches to the main queue asynchronously, and you have the image. So in our view controller class, we don't have to deal with any kind of asynchronous multi-threaded code. So what I'm going to do is let's say image downloader dot downloader dot download from URL. So yeah, I'm going to use this URL, which is unsplash.it slash 224 slash question mark random. So there's a really nice website called Unsplash, and you can request it for a random image and it'll give it to you. 224 is the size of the image. Now why I've set this to 224 I'll explain soon. And completion handler, let's just do that. So over here I can say self.imageView.image equals image. Let's just run this out and see if it's working. So you can see the new iPhone simulator is really fancy. It actually has the iPhone bezel around it, which is nice. And it also has the wallpaper. That's nice. All right, let's go hit the refresh button. There you go. Let's hit the refresh button again. And we should be getting a random image. There you go. All right. So we're able to get random images from the internet. So let's try to classify these images. Now, to do that, as I said before, I'm using the Google Net model. All we have to do is just drag and drop this model file into your Xcode project and make sure you're copying it and it's added to your target and finish. And when you go over here, you can see that Xcode is giving you all information that you need for this. It's telling you that the name of this model class is Google Net Places, and it takes in an input of a scene image, which is basically an image of RGB, and the dimension is 224 by 224. So that's why in my URL I had the size set to 224. And output, it gives you a dictionary of probabilities, and it gives you the scene label, which is basically the most likely scene label, and it also gives you a dictionary of probability of each scene. So let's try to print out this scene label into our into the output label. Let's click on this arrow and let's look at the Swift generated source. So you can see that the class is called GoogleNetPlaces, inherits from NS object, and it has a function called prediction, which takes in a scene image, which is of type CV pixel buffer, and it returns the output to you. All right. Now you need to be certain that the return type here is GoogleNetPlaces output. Let's look at GoogleNetPlaces output. This has the scene label and the scene label probabilities. So let's go back to code, which is our viewController.swift. Now once we have the image, we need to convert this image into a CV pixel buffer, and to do that, in my extensions.swift file is a function called pixel buffer that returns an optional CV pixel buffer. This code is easily available on the internet, and it's also going to be part of my Git repository when I upload this code, so don't need to worry about this. So let's go back here and let's say let CV image equals image dot pixel buffer. So the type of this CV image is an optional CV pixel buffer. So let's just say guard. All right, now once we have this, let's say scene now model output equals GoogleNetPlaces dot prediction. Let's go back here. So GoogleNetPlaces, it's an instance function prediction. So okay, and let model output equals model dot prediction, and we need to give it the CV pixel buffer, which is CV image. So this could throw, so let's just say try. Else return, and here I can say self dot output label dot text equals model output dot scene label, and let's see if this works. So refresh. Okay. So the most likely label for this is canyon. Let's refresh. This is a driveway. Okay. This is desert or sand. It kind of looks like snow to me. Is this an airport terminal? No. Boat deck. Okay. It's a bridge. Well, there was also another thing, which was the probabilities. Let's just try to print out the probabilities and see what are the other things that it predicts. So model output dot scene label probabilities. Underwater coral reef. And what are the probabilities for that one? Could be a stadium or a baseball with that probability. Canyon or an amusement park. Oh, interesting. Nope. Nope. Yeah, I see an arch in there. That's a highway. Could be a marsh. Could be an airport terminal, but yeah. So maybe the model that I'm using is not absolutely correct for this data set. So all you got to do is just download the other models from the Apple website and just drop them into this Xcode project, and you can see which model works best for you. So that's it in today's video, which was about introduction to Core ML. I'm going to put this all the text and information for this on my website, which is indianios.guru, and all the code will be available on my GitHub repository. And the link to this is going to be available on my website and on my YouTube page as well. So see you guys again next time.